paper, question 12. Right, last question of the paper, question 12. I've had to do some kind of cutting and scribbling things about to try and get it all on a page because there's a full page of data in the exam question. The table shows the boiling points and structures of some isomers with the molecular formula C6H12O2. Right, and so we have, what's this, hexan, 1, 2, 3, 4, 5, 6, so hexanoic acid. You've then got a branch of pentanoic acid, and then we've got 2 branches of bute. And then we're switching now to esters. So this is a methanoate, but we've got a straight chain attached and we've got one with a branch. And still in the methanoate, but we've got 2 branches. And then we've shifted this to be ethanoate, and we've got a straight chain, and then we've got ethanoate with branches. Okay, and I think you can already see the patterns that are coming in with the boiling points, but let's have a look. Okay, name the intermolecular force which accounts for the higher boiling points of isomers 1, 2, and 3. Here we go, 1, 2, 3. Why are they higher? It's got to be because of these causing more, or allowing, hydrogen bonds. Okay. Use the information in the table. Describe 2 ways in which differences in structures affect the boiling point of isomeric esters 4 to 8. Okay, so here is our isomeric esters. Right, so we shifted from methanoic to ethanoic as our standard starting acid. So we can see what happens here. Here's if I've got methanoic acid as my kind of parent, and here's what happens with ethanoic. Here is the same idea with 1 branch. We've got 1, no, that's 2. Let's go with the 2 branch one. Then here's parent methanoic acid and parent ethanoic acid. So carboxylic acid in ester, okay, increasing chain, increases chain, decreases boiling point, because we've got 132 drops to 126 and we've got 119 drops to 98. Okay, or you could have said or you could have said it the other way around, that you decrease the chain of the carboxylic acid in the ester, increases the boiling point. And then I suppose your other one has got to be branching. Okay, so branching on the alcohol side, 132, 125, 119. So branching increases, branching increase as, let's make this a sentence that makes sense, as branching increases, boiling point decreases. That's it. That's your 2. Predict the boiling point in degrees C for the isomer given. So this is the one that's missing in the set. So we've got 1 branch for the ethanoic acid being the parent acid. So we're somewhere in between these 2 is the idea. Right, so basically they're accepting anywhere in here. So they're accepting anywhere from 99 up to 124. I'm assuming that they're 1 up from here, but they're 2 down from here is because of the jump down on the methanoic side. Okay. But any number of those. Right, carbon-13 Nmr spectroscopy is a technique that you can use in chemistry to determine the structure of organic molecules such as esters. I'm just going to see if I can shift this to the side. Yeah, okay. Right, in a carbon-13 Nmr spec, a carbon atom in a molecule is identified by its chemical shift. This value depends on the other atoms bonded to the carbon atom, which is known as the chemical environment of the carbon-13 atom. Carbon-13 chemical shift values are shown in the table below, this one. The carbon-13 atom in each chemical environment has been circled. Okay, so we're saying that for a carbon which is attached to 3 other carbons up here, we get a shift of 25 to 35. If it has one hydrogen attached and 2 carbons, then it's a 16 to 25. If it's a carbon which is attached with an oxygen and a carbon on this side and 2 hydrogens, 50 to 90, and so on. Okay. The number of peaks in a carbon-13 NMR spec corresponds to the number of carbon atoms in different chemical environments within the molecule. The position of a peak indicates the type. Okay. The spectrum for ethyl ethanoate is shown below. Match each peak in the ethyl ethanoate spectrum with a number to match the carbon atom in ethyl ethanoate. Right, let me just again pull this down a little bit. Right, okay. So let's see what we've got for each one. Let's look at carbon 1. Carbon 1 is a carbon with 3 hydrogens attached to it and attached to a C double bond O. Okay, so this carbon environment is this one here. Okay, so I'm looking for a 20 to 50 shift. So my 20 to 50 shift, here's my 20, here's my 50. That one there must be carbon 1. Okay, carbon 2, is the carbon at C double bond O. Find this one, here it is here. I am looking for a shift at between 170 and 185, so here's my carbon 2 shift. And my carbon 3 is a carbon with 2 hydrogens attached to a carbon and attached to an oxygen. This looks like this. Okay, 50 to 90, that must be this one in here. And my 4th carbon is, where are we going, a carbon with 3 hydrogens attached to a carbon. Carbon attached with 3 hydrogens attached to a carbon. There we go, 10 to 15. So there's number 4. So it's a bit of work, but if you just spend your time not panicking about, just read it very carefully, it's all there. Okay, and that's the mark. Determine the number of peaks that would be seen in the carbon-13 NMR spectrum for the ester shown below. Okay, so number of peaks, it tells you, in a carbon NMR spectrum corresponds to the number of carbon atoms in different chemical environments. Okay, so we're looking for different things for the carbon. So let's look at this carbon. That's, oh, sorry, I've made that. Let's have this one. Okay, here's a carbon with 3 hydrogens attached and a carbon. Okay, this one is exactly the same. It's got 3 hydrogens attached to a carbon. Okay, this one is on this side not the same because it's got 3 carbons, 3 hydrogens attached to a C double bond O. So I'll just get rid of that. Okay, so next, let's have a look at the next carbon. This is a carbon which is attached to 2 carbons on either side. 3 carbons and a hydrogen. Okay, nothing else looks like that. So we're up to 2. This one has 2 hydrogens, a carbon and an oxygen on either side. Nothing else looks like that, so we're up to 3. This carbon, C double bond O, it's definitely nothing else looks like that. And as we already said, this one was different again. So just count my colours. 1, 2, 3, 4, 5. Last question of the paper, and that's you done.